Hey everybody, it's Eugene Liscio here, and welcome to Click3D. This is the program where we talk about photogrammetry and how you can use your digital camera and some software to produce some really excellent 3D models. Today we have a special treat. So I have a guest today who's going to talk to us about 32-bit imagery, my very first interview on Click3D, which I'm really excited about. And his name is Barry Bassnett. He's a photogrammetrist with over 40 years experience, starting with the UK's national mapping agency, the Ordnance Survey, and then working in a vast number of cartography and land surveying projects. He's worked on every continent in over 80 different countries around the globe, as well as the conventional applications, close-range applications in industry, large object metrology, and 3D modeling. So from cars and aircraft to ships, architecture, oil and gas, nuclear, civil engineering structures, and inspection, and all kinds of different things he's worked on. But what we're interested in today is that for the past 10 years, he's been specialized in high or ultra high definition HDRi and 32-bit photogrammetry and photography. So it has a wide range of applications in many different fields. And today he helps companies through Astrea. It's based out of the west coast of Scotland and using photogrammetry, 360 imagery to help in LiDAR colorization and maximize the potential of drone and ROV image capture using 32-bit techniques. He also trains people in photogrammetry, surveying, and virtual reality content capture. And I'm very pleased to have him here today. He's going to help us share some knowledge. There he is. So Barry, welcome, and thanks for being here today.
Oh, thanks for your time, Eugene. It's great to be here, and really interesting to share with a fellow enthusiast.
All right. Well, let me ask you first off, I'd like to ask about you and a little bit about your, excuse me, I'm choking up here, your background. Tell me about how you first got interested in photogrammetry. Like, you know, just before you were there, was it something you studied at school? Was it something that interested you? What got you into it?
I've been photographing since my dad gave me a Russian digital SLR camera when I was 12, and I've always been passionate about it. But then I saw an advert in one of the national newspapers recruiting ordnance surveyors, and it just seemed like a fantastic romantic job. And so I applied and fortunately got in, and that was the first day of it. Amazingly fulfilling career, really. It's given me opportunities to travel and to share and see things many people don't get. But I'm guessing really photogrammetry first came to my mind because I didn't know how they made maps, and basically it's from aerial photographs, and that's where it first started.
Nice. And since then, I mean, you worked in I mean, your background is you've done so many different things with photogrammetry and applied it. So there must have been a lot of learning along the way.
Well, yeah, I'm from that generation that used to have to go out with blackout material and gaffer tape and development chemicals in the luggage, and then convert the hotel or bathroom into a dark room. We were taking 24 images at a time and then changing the film back. It was all medium format. Now I look and see what's gone on, especially in the last few years, and the push of drones and the impact that's had on photogrammetry. And I look and I go, this is just another planet for me. But fortunately, I've seen both the beginning, and we're looking into the future of what photogrammetry will be able to deliver us. And the amazing thing is how many things it's used for. People understand from photogrammetry, it's about measurement and producing measurements or models, whether that's ground terrain models or 3D models of buildings or artifacts. But it's used in a huge variety of applications that I'm fortunate to play about with. And now we have a whole slew of different technologies, softwares, processing in the cloud, which means we can deal with amazing amounts of data. Previously, I'd have had to shine my torch to a negative in a hotel room in Iran. Right. As has happened. Now I can do everything from wherever I am, my COVID bunker, and share information. I don't tend to do much of the data capture stuff myself. I do not own a drone, for example. I'm more interested in the images that you can get out of standard conventional cameras or photogrammetric processes.
Right, right. Well, let's start getting into like some of the application stuff, because I want to definitely speak to the concept of 32-bit imagery. I want to talk about the equipment, about the software, about some of the things you're doing to enhance these images to get the best quality data. And but I do want to ask you one thing before, and that is the work you did with the America's Cup team, and I'm curious about
Oh,
what you
okay.
did there.
Oh, this is going back several years now, but the America's Cup team, about 20 odd years ago. Yeah. Unlike all the other teams who had computer aided design, the America's Cup team at that time designed it. You designed their boat using some very old traditional materials. They used piano wire weights and what they call buttock lines, and produced wooden models of difference. Then they put these into tanks, and the problem is they would shave bits off the model and they didn't know what shape it was. So they got me in to use photogrammetry to produce an as-built model, which they then scaled up 12 times to produce the GRP mold. And we didn't get very far with that, but it was just an amazing experience to work on that. And I've also worked on similar rebuilding, re-engineering projects, and that's largely what the closer range industrial photogrammetry was about. How do we measure this and produce a model of it, or a drawing of it, so we can accurately replicate it? We're used to photogrammetry being to 1 centimeter, a couple of millimeters. That sort of, we're going down to 1,000th of an inch, a millimeter, 0.01 of a millimeter. But that was great. I got to play with these massive wooden bits and digitize them. And yeah, it's one of my more interesting jobs. But to be fair, every day is an interesting job for me.
Yeah, sure. I'm sure that the applications change, and you get all exposed to all sorts of different things.
Yeah.
Let me, I just want to read something, or sort of to quote you, because I think it really sets the stage for what we're going to be talking about next. And there's a quote here I have from you. It says, "We often forget in photogrammetry that it's all about the image quality, not just the camera resolution or payload of the drone or the speed of the software. Without great image quality, it doesn't matter what you use." And I think that's a great quote, because a lot of people forget. And even I just did a video the other day where I was looking at a number of different models that were created by people in one of my classes. And there's two things for me that I always try to push, and that is getting the best photograph possible. And the second one is knowing where to take or how to take the photographs for photogrammetry. And those two things are super important. So you first probably were one of the first people to coin the phrase 32-bit imagery. And I'd like you to explain what that means and how you maybe got started in all this.
Okay. 32-bit imagery is a phrase I quoted because what we're talking about is a lot of professional photographers will understand the concept of high dynamic range and HDR processing. A lot of that's been hijacked a bit, unfortunately, by the marketing people. And what one man's HDR is another man's LDR, low dynamic range. 32-bit photogrammetry is the way and the format that you or I process imagery. Now, you can do it, 80% of the jobs that you'll do, you don't need to do this. But photogrammetry is all about loss of data, overexposure, underexposure, because you get a high contrast range across the image. And whenever you get that high exposure look on the whiteout or the blackout, you lose data. You get big holes. So what I've been doing is using some more, not advanced, because to be fair, I could teach anybody how to do this in an hour or so. It's not hard, but it does take a bit of application to fully understand what it is you're doing, and you can produce sensational results. I mean, a lot of what I'm talking about doesn't come from the survey or the photogrammetry. This comes from CGI. They've been doing this for years. Image-based lighting is what we're really talking about, and virtually every CGI, everything since Harry Potter has been filmed in these formats. But it's probably best to go back and explain a little bit about where this comes from. I think we're used to using JPEG TIFF formats, and they're great, but basically what they are is we are tied to the settings of the camera at that time we captured that JPEG. we can't do very much with the image. Now, HDR or 32-bit imagery gives us what we call a magical fourth channel. We get RGB values for the color, and we're used to being able to change the color and hue in Photoshop and sliders and stuff, but the fourth channel looks at radiance and or luminance of that pixel. So it turns out that if you've got the right tools, and most of the big photo, editing softwares have it, then you can change the contrast. You can change and bring out detail in shadows and bring out detail in the highlights. Now, there are some systems out there that say they do HDR, and that's fine. They do. They apply a constant change in exposure right globally across the image. That works, but it compromises the other parts of the image. So I can adjust it so I can bring out shadow detail, but then that screws up the rest of the image.
I see.
What we do is we use a little bit of AI, and we also do some fancy stuff with the 32-bit file images to produce what we call luminosity masks, which help us to isolate the areas where we can tweak. You've all seen the histograms and things in cameras and DLS and and the DLSRs that we use. We live and breathe by the histogram.
All right.
But going back a bit, we're all used to these JPEGs and TIFFs, but I think it's 1987, a guy called Greg Ward, who's sort of like the father of HDR, and he's a giant on whose shoulders we sit. He had a software rendering company called Radiance, and he came up with a file format called .hdr, high dynamic range. And for those people who don't understand high dynamic range, in any image, it's the contrast between the whitest white and the blackest black. And you're measuring the gray midtones to actually help balance everything out. So he came up with a .hdr format, and that sort of got everybody's juices going. And there was lots of hubbub in the CGI industry and things like that. HDR is the image you will see. Photoshop will take in .hdr. Some of the photogrammetric softwares will take in .hdr files. Okay, but then around about 2000, there's a guy called Florian Keynes, I think, who worked for Industrial Light and Magic, and they came up with a format called open.exr, which is a 32-bit format, and that is currently what I use mostly for processing. Okay. So you can get a .exr file from using HDR processes. Now, many people will know that you use HDR, or you can compile a HDR image by having bracketed images. You keep the same f-stop, but you change the exposure. You keep the same white balance. That's really important. Mm-hmm. Don't change that. But then what you can then do is you can manipulate the image and come up with any lighting system you like within some limits. The great thing that's happened for me in my industry is camera technology, which now means the dynamic range of the camera and how many f-stops it will cope with is how I choose which camera kit I'm going to use.
Right. Well, I'll tell you what, before you get to that, you had an example that I was hoping that we could share, because I think it really highlights the problem. And,
can you see my screen?
Can you just, if you hit share screen, then I'll...
Oh, yeah, of course. Sorry, beg your pardon. Share, that's it. Share screen, sorry.
No problem. And it's just coming up here in a second. Oh, for some reason it's not popping up yet. Why is that?
That's all right. It's because I was sharing the wrong screen.
There we go.
Okay.
Oh, that's our screen.
That's our screen, and it will be, I'll get rid of that and I'll go to my screen. There you go.
All right. Perfect.
Can you see a big gray thing there?
Yes. So tell us, maybe you can tell, so what did you use to capture this? And there
are a number of different cameras you can use. There are dedicated 360 HDR cameras, which are phenomenal and really good. But this was captured just with the standard off-the-shelf Sony Alpha 2 and what lens have I got on here? I've got I'll show you in a second. It's a Sony, it's a Zeiss 18mm lens. using a straightforward Nodal Ninja bracket. I mean, there's nothing special about, well, Nodal Ninja is a nice company and they make great stuff, but there's lots of brackets out there you could use. The key is capturing everything not as a JPEG, but as a raw image. And so anything that will capture raw and will give me a reasonably good range of dynamic range, well, good. I mean, to be fair, there's probably, you could use most of the major manufacturers. Most of them now have a dynamic range of between 13 and 15 f-stops. And we can talk more about the techniques that you use, but but I've just taken, I think, 7 images and stacked them up on this one. Now, this is it's for anybody who lives in Scotland or has travelled up will recognise this. These are the kelpies. These are statues by the side of the motorway. But this is sort of fairly typical of the problems that you get. So I've taken a photograph here, but this is ideal. It's a lovely sunny day on you know, you would say that this is the best day. Well, people who don't do photography, photogrammetry would say this is the best day. Me, best day is when it's grey and overcast.
Yes.
Okay. Anything with sun, low sun, shadows, it's just no, please. So when I'm looking at us going out on site, the first thing I do, and if I've got lots of grey clouds in it, I breathe a sigh of relief because it saves me hours.
Yeah.
But unfortunately, photogrammetry isn't like that. There are places in the world where you just can't avoid this. You try taking photographs in Australia or California or Texas or the Middle East, you're always going to have these issues.
Yeah. So it's these areas here where you're getting the very bright or very dark whereas you're going to lose detail.
Yeah, so I can lose information. So there's texture in here, but I can't see it. This is just going to be white. It's going to be like, you know, if I try to stitch in, and this is really important for 2 or 3 things. One, most stitching software allows you to have an overlap. So you've got to have data in that overlap. So the more data you've got in your photograph, the better. Second is I'm using it for rendering or I'm producing a wire mesh, or I want to colorize my point cloud because you could use the same technique for doing that. I'm going to have areas which are just white, and it's patently that's not it. If I'm capturing reality, guess what I want to do? I want to capture reality, not the limitations of my camera or how rubbish a photographer I happen to be. And one of the big benefits and one of the big areas in this field is to allow people who are not necessarily skilled in photography to be able to take quality images where you can extract the data out of it. I'm not interested so much in the aesthetic quality of a photograph, just how much data I can get out of it.
Mm-hmm.
So
can I ask you, sorry to interrupt, but could I ask you, like, so when you get into a situation like this and you approach, you know, one day it's cloudy, one day it's sunny, whatever, how do you decide what images to take? Or is there just a standard set you always take, you know, is reliable, that works every time?
I mean, that's probably the benefit of been doing it for a few years. You sort of instinctively know I don't have to do a spot reading or a matrix reading to know what I need to set it at. The critical issue to do with photogrammetry is to try and maximize the depth of field. So you always want to have it at the smallest f-stop you can. So I'm normally shooting at 6.3 or bigger or smaller apertures because I want to maximize the depth of field.
Mm-hmm.
The problem with that is that compromises low light situations. So then for me, none of these images are taken by hand. They're all taken on a tripod because I get into that habit, but occasionally I have to do 2, 3, 4, 5 second exposures with a remote release. So a tripod for me is the critical piece of kit.
Okay.
And in some ways it's good because it goes back to the old ways of framing photographs. But for me, I'm constantly looking at the overlap. So I always have, if there's a grid in the viewfinder that I can use and project, I'm using them. But generally, I'm trying to get the smallest f-stop I can, but try and shoot. As I'm using a tripod, it really doesn't matter too much if I'm over. You know, I'm not worried about handshake or motion blur. But the interesting thing is that you can use exactly the same thing on drones as well, but we can chat about that shortly. But just to show you, for example, this is a 32-bit .exr image, and what I can do with this, and I'm just going to change this with my mouse, is I can change these the lighting in this so I can get down to this detail and change it. In photo editing, I can then apply what's called luminosity masks to different levels and then change the exposure or the contrast or the saturation or whatever other funky details I've got in the photo editing just within that mask. So it means what I'm getting is an almost perfectly lit object. Now, if it's perfectly lit, that means then I can export that and I can do all sorts of things. I can substitute and I can play with different lighting schemes to see what would happen. But primarily what I'm trying to do here is I'm trying to get all this detail here so I can export that into my photogrammetric software processing so I produce a consistent image.
Right.
The problem most drone people have is, you know, majority of the time it's going to be fine, especially in England or Scotland where it's permanently dull. But you've got, if you're doing photographic inspection, then you get shadows from chimney pots. I mean, we've had some fantastic days weather recently, low sun, and it looks fantastic, you know, photogenic, great, but useless for photogrammetry. So what 32-bit does and processing in EXR and then exporting back into TIFFs that can be used, because the workflow, I mean, we'll talk more about the workflow, but the workflow basically is we take it, convert it from an 8 or a 14-bit image into a 32-bit, which allows us to play about with this. And then we export it back. So as a JPEG or as a TIFF, whichever, Pix4D or Metashape or Capture in Reality or Concept Capture or whichever software you're using, or you use Zephyr, don't you, I believe? Any of those will be able to use. It's all about extracting the data within the image, not making it look pretty.
Right.
That
makes complete sense. So equipment wise, really simple. I mean, your digital camera, a good lens, something like a Nodal Ninja or could be a more expensive automated solution. Good tripod.
Yeah. I mean, this is my kit. This is what I can, with this, I can do virtually anything in the world. And a tripod, I've got a remote release so I can do longer exposures if I need to. There are some fabulous dedicated cameras out there, but they're going to cost you $35,000, whereas my kit costs $3,500.
Okay. And then you talked about the camera settings. So you talked about, making sure that you have a fairly high f-stop number, like, 6 or so or higher for the depth of field. ISO is probably down low. You're probably down at 100 or so.
I normally am 100. Pre-well shoot. I would prefer to sacrifice, because I'm tripod shooting, and that sounds like it might take some time, but once you're into a rhythm, it really doesn't. I mean, not at all. You just get into that. But I'm generally shooting about 100 ISO. The quality of digital sensors these days, and it's the sensor, not so much of the brand, because between us girls, one company makes most of the sensors for everyone. No, I'm not saying who it is, but someone will. Yeah, okay, Sony. But anyway, so you can it's about more, a lot of the camera selection is more about what you're used to. Some people like a bigger chunky, like a Nikon 850 is like, you could do anything with that. That's the most amazing piece of kit I've ever come across. Sony Alpha 7s have changed. They've come out of nowhere and suddenly they're dominating the marketplace. Canon are great. All of these, you're not going to get bad, but sometimes you don't need a Hasselblad to photograph some pipe work.
Yeah, and it's really interesting too when talking about cameras. So I have it's a point and shoot, a compact camera, but it's got the larger sensor inside of it. It works great for me. I bring it in. Sometimes sometimes it gives me better results than my digital SLR, which is kind of strange. But
well, no, it's true. And to be fair, I mean, these things, you can do amazing stuff with this. I mean, I think the difference between you've got, everyone can capture amazing photographs with what's in an iPad or Samsung or whatever flavor you use. And I do use my iPhone occasionally for infill and stuff like that, just because it's handy. And the image quality is fabulous. The problem is that professional photogrammetrists have to be able to hit the quality of photograph every single time. Whereas an amateur guy with going out, they can produce one great quality photograph every 100 or 1,000 images. Photogrammetry is about consistency. That's it. And there's only three things that matter in photogrammetry: repeatability, repeatability, and repeatability.
Yes,
That's it.
well said, well said. Let me ask you about, you mentioned some software, but let's talk about software and workflow. So you've gone in, you take your photos and everything's good. So what do you do with the images now that you have them? What kind of software are you using to process these?
Okay, well, actually, you've caught me at a bit of a crossroads, because I've primarily used Lightroom mostly, because you're taking loads and loads of images, and then mostly Lightroom just great for organizing folders. I've now started using another software, Capture One, largely because I think it's a lot easier in some ways, and it's got some great file renumbering kit. But then there's a number of plugins that you would use for 32-bit processing. There are a wide variety of those. Historically, the one that most people have used, and to be honest, my favorite, no plugs, is Photomatix. Photomatix is just brilliant. How they managed to do this. And the main reason I use that is there are probably slightly better tone mapping things out there, but it allows me to batch process 100 images, so I can get consistency, because sometimes you have to titivate or polish a handful of images within the whole range of the ones you're doing. Sometimes you have to change them all because you've got the wrong settings or the wrong ISO, or you haven't noticed that you've put it at the wrong f-stop or whatever. Providing you capture it in RAW, there's lots of things you can do later on. So we use Photomatix or Photomatix plugin in Lightroom. I'm now using Capture One primarily as my primary tool for organizing and doing some basic stuff. But the interesting thing about that is it allows us to, or the other bits, and there's some AI stuff that I do, which is our own software, which allows us to produce what's called luminosity masks. Now, you all know about masks to do with the color or separating out a background or things like that. Now, those are largely based on color. Okay, and some are based on focus, and depth of field and things being out of focus. The ones that we use are using luma values, brightness values, so we can do like an onion, but images stacked up of different areas of brightness, and then we can apply. So say, for example, I'm taking a photograph of a bridge. It's lovely lit, but there's dark shadows underneath. Using the masking tools, what we can do is then illuminate and bring the detail back out of those shadows without affecting the rest of the image. There's people out there and their systems, they say they use HDR. Well, they do, and it's great. And for 50%, 100%, a percentage, it's going to get you out of jail. But there's other cases it just won't. Okay. And that's what we deal with. Quite often we're dealing with heritage stuff or crime scene documentation or shooting at night where there's hardly any light at all. Like, we just finished a number of projects doing some tunnels in Wales with just a head torch, and the results are phenomenal. You might see it on LinkedIn if anyone wants to go and find me, and I'm always talking about stuff like that on there.
So let me understand then. So when you're talking about the luminosity map, if I'm understanding it correctly, it's for example, you're able to control specific areas of the image and adjust the levels so that it's not an overall, you're not adjusting the image overall, the whole image. It's certain areas are controlled.
Yes, exactly.
Others. So you can balance everything. Okay, I think I understand now. Yeah, I think that
exactly. So when you come to select the masks, you can set it to a range. So you should say, now I live and breathe. I'm not necessarily looking at the image. I assume it's in focus. Okay, I'm using autofocus. I've got the right depth of field. I assume it's in focus. The problem when I'm looking at an image is I don't see where the little clippings are. So for me, I live and breathe by the histogram. So the histogram is the most essential tool that you need to be able to use and understand when you work in 32-bit. Because what you're trying to do is look, and the normal histogram will be something. I'm trying to do this the wrong way around. So you got the bell curve. I should do that the other way around because I'm reversing, but you understand it. Okay. Yes. At either end, you're getting the blackest blacks and the whitest whites. All right, and those are clipped, and those areas are where you lose the data. Yeah. So what we can do with the masking is we can take those and we can say, okay, just show me these bits at that end that I need to play about with, because the rest are fine or good enough. And that's the other issue. I'm not one of those pickety guys who will worry about the tonality of the boulders in their landscape. Yeah, I just want to see the detail that's in there.
Mm-hmm.
So this is about playing about with an image so you can maximize the amount of detail that is there. You know, HDR has got a bit of a bad rap because people have taken it and they're using it for gaurishness and these really punchy, posterized sort of space cadet images, which are fantastic, but I'm not eye-catcher in reality. And the reality is what texture is in that rock, what detail is in that wood, what cracks are in that wall, what hairs are in that crime scene.
Yeah, it's not so much a creative work as it is so much trying to extract as much data or information out of the image as possible. Right?
No, that's the thing that I think from a sort of an older guy looking onwards at the young whippersnappers who are throwing the drones up in the air and pressing a button, getting all excited by, oh, got an SD card, bang, 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 and then they produce a model and you go, yeah, but what about all the shadows?
Mm-hmm.
So for me, it's I'm more of an old grouch in terms of image data. I'm looking at data. I'm not necessarily looking at, well, don't get me wrong, I do landscape photography as a hobby.
Yeah.
And yeah, I know all about, you know, putting darks in so that punch the image and you know, and make it more aesthetically pleasing. I'm leaving that to my retirement. I'll do that then. But right now I'm trying to make the best models and capture reality in as real a way as I possibly can.
Okay. Well, you mentioned drones before, and I want to ask you about that as well, because with a drone, if you're flying up and you want to achieve the same type of results, how do you work with drone imagery?
Okay, it's a really good point, and a lot of people get worried about the fact that the drone is always moving. Well, yes, it is. The plain fact of the matter is that there are algorithms out there, and the one that we've developed actually allows us to compensate for vibration or movement. So any 32-bit requires us to take a number of images, 5, sometimes 7. Our algorithm and the AI that we use allows us to overlay images pixel perfect, providing we've got one image that we use as our datum image. Now, that's not to say it will compensate. That will compensate with the changes that you would get from the drone positioning, but it's never going to compensate for me trying to take photographs of a field of wheat blowing in the wind, or trees, branches, and things like that. I'm not going to be able to get around that. But it does allow us to remove a large amount of what's called ghosting, and also to allow us so we can stack those images up over one by one. We can't, and there's a sort of like a chicken and egg. Sometimes we can stack them up, but sometimes we have to get better texture before we can stack them up.
Mm-hmm.
So we've got more patterns. Photogrammetry is all about pattern recognition. SIFT is all about, and the way it works is it looks for patterns and radiuses of patterns and matches these up and goes, I can see that in that image and I can see that in that image.
Right.
That must mean they're together, and from that I can calculate the coordinates, X, Y, Z coordinates, and the pitch, roll, and yaw of my camera. All these massive matrix equations I had to learn with log tables and slide rules, and now somebody just presses a button, has no idea that this stuff's going on in the background.
Mm-hmm.
So drone footage we can. Yeah, there are limits. If it's blowing a gale, we can struggle. But providing we can get an overlap around about 10-15%, we can stack them up.
Okay.
Okay. There are limits to it. I'm not saying it's going to work every time. But we can only shoot that in RAW. And there is a problem with it, in that if you shoot in RAW, the download speed the SD card is much slower than it is with the JPEG. So if you move on and you're moving, you've got to download that image. So
right.
It can take longer to do, but you will know if you're going to get bad quality, because you can just see. Any good drone pilot who professes to be good should be looking at the conditions of light that he's got. The interesting thing about photogrammetry, as I try and remind people, it's the word photo. photo doesn't stand for photograph. It stands for light.
Yes.
It's from the Greek for light.
Yes.
And we are light engineers. We are light capturers, which is a bit of a grandiose term for pressing a button when piloting with my joystick. And that's essentially, if I'm doing drone photography, or I'm doing close range, or I'm using ROV to do underwater photography, that's another story completely, by the way.
Yeah.
But it is all about capturing light. And the better way you can capture light, I'm more about, if it takes 50 minutes as opposed to 45 minutes, okay?
Yeah.
It's like another 5 minutes.
Yeah, it's not a big deal. Sure.
It's not a big deal because it will save you much more time back in the office when you're processing it.
Yeah, that's cool. I love that term. We are light engineers. I like that. And you're referring to, in photogrammetry, photos light, gramma meaning to like write or draw, and then metron meaning to measure. So yeah, that's fantastic. Let me ask you a question about putting it all together then. So you've processed all these images, and then you've got all these images. So now you can run them through whatever photogrammetry package you like, or you want to present maybe, for example, like 360 images in a certain way. So what are some of the outputs or some of the deliverables that you provide?
We do two things. We don't tend to do 3D. We don't pretend to do the 3D modeling these days, largely because there's so many people out there can do it. Once you've got good image, to be fair, if you can fog up a mirror and press a button, you can do this. It's not hard. Okay. The difficulty comes when you are trying to arrange that coordinate system to be in a real world coordinate system, where you are changing that, and you actually got to have some proper geodetic land survey control skills to orientate that to the coordinate system everybody wants to work in, whether that's GPS coordinates or a local coordinate system. That's something else. For us at the moment, the thing that seems to be going on is 360 imagery, and what we call smart 360 images. And the reason that they're more popular is they're much easier to share. The problem with big OBJ files and mesh models and point clouds is amazing tools, but unless I need to measure dimensions, and I mean across the whole site, you don't necessarily need them. There's a paper coming out that I've written called "What's the Point of a Point Cloud," which is like, yeah, they're fantastic. I use a point cloud. I use a scanner every day of the week. I use it for control, so I can layer instrument and things on, and we're doing it for other things. But the 360 imagery thing seems to be pushing up an open door, because it's really easy to download a 360 image, and the images that we do are not just images, they're knowledge user interfaces, so we can attach other information to them. So think of Google Street View on steroids / Wikipedia.
Yeah.
But the thing about 360 imagery is one man's 360 imagery is another man's 360. They're just poles apart. It's a bit like me buying a Land Rover and sitting on the drive and only using it for the school run. Okay, you could use it for so much more. Yeah. What we have found is that unless you spend a lot of money on the top end ones, there are 360 cameras out there which are good enough to do certain things, but not good enough for everything. For example, if you want to use 360-degree imagery for photo modeling or photogrammetry, you can. You can use a 360-degree imagery, providing you've calibrated its nodal point in terms of the optical axis of the lens, not the camera, is directly in line with the mechanical axis. So you've got no parallax. As I rotate it around, I'm not moving it side to side. If you don't have that, you cannot use those things for 360 imagery. Agisoft Metashape, and there's a couple of others, will take 360 imagery in. It's a really cool tool. It's really important because it's used largely. Every CGI film that you see uses 360-degree imagery to produce the HDRi files, the lighting files that they use. What do I mean by that? Well, if, say, for example, we're in a film and you're the actor and I'm the monster, or I'm the CGI person, okay, in order for them to make that monster look real, it has to be lit in exactly the same way as you are.
Mm-hmm.
So what they do is on site, they go in with a camera or some device, and there's 3 or 4 different ways of doing it. And they capture a 360-degree radiance image, a HDRi 360-degree image. Then they give that to the CGI people, and then they can then manipulate that and light the image and bake those materials rendered with the same lighting conditions. Essentially, I'm doing the same thing, but we're just projecting out CGI type imagery to a 360. That allows us to do certain things. It's much easier. Anybody can use Google Street View. Very few people can actually have got enough CAD skills to navigate a point cloud. Yeah. They get lost in the wall or lost in the pipe and they don't know where they are.
Right. That's great.
Okay. And the OBJ files, that is great because that actually gets us more into a workflow into reality platforms, the games engines like Unreal and Unity, which is where the market's going to go. In my opinion, it's not the survey people who should be looking at the CGI market and saying we need to create content that they use, not it's just used to produce a 2D drawing or a Revit model.
Right. Hey, Barry, so you mentioned an article that maybe is it still coming out, Point in the Point Cloud? Is that still coming out?
Yeah, I'm going to release it. I'm a bit nervous about it, to be honest, because it's going to upset an awful lot of my friends who work in scanning. Actually, it doesn't. It actually doesn't. The point of it is that scanning is an amazing tool. I've been scanning for 20 years, probably every single week of my life since then. Since the very first days of Mency scanners from France, which was about the size of a Dalek and would give you a hernia and needed 3 people to use. And now I've got the Farah scanners or the BLKs and things, and you can just stick them on a pole and dangle them down in a void, and they're just amazing.
Yeah.
And if I need to produce 3D dimensional models from them, I would tend to use a scanner rather than photogrammetry, if I'm honest, just because they're a lot quicker to process. And I get a much more fuzzy feeling about the accuracy. Okay, because photogrammetry is a bit of a science and it's not a linear accuracy. As you progress further away from the camera, the accuracy does degrade. That's something people don't get. However, if I just want to show people, whether it's the CEO or the janitor, whether it's the head designer or the guy who's digging a hole in the ground, 360 imagery is much the quickest way. I can produce a digital twin in a day. I don't have to collect a point cloud. I don't have to tidy it up. I don't have to do all that rubbish to remove the buses and the people and all the reflections through windows. And then I can share it really easily on the web because everybody can look at this stuff. They don't have to download anything. Point clouds are a phenomenal tool, but I can't colorize a point cloud in a tunnel at night, or a night scene. But I can if I take a photograph at the same point in 32-bit, and then I can colorize any point cloud you like.
Right.
Okay. Right. So for me, I'm at a little niche end of the VR reality capture side. Most times you're not going to need me or what I do, but there are times when you can't do what you want to do without 32-bit.
Right.
And it's not hard to master and it's not hard to understand. It just adds a little bit to the workflow, but it does, and it has amazing impact on VR, reality capture, architecture, building, BIM. And then CGI. I could go on. I have a great job.
Well, so how can we're going to wrap up here in a second, but how can people find out more, or where can they reach you? I know you're on LinkedIn.
Well, they can get through LinkedIn. If they go to our company is astreadigital.io. Just drop me a line. There's a contact form in there. If they want to reach out to me through LinkedIn, that's probably where most people get in touch with me. I seem to spend my life on there at the moment, especially after a couple of posts that have gone just nuts the last couple of days.
Is it like this, like what I have on my screen, astreadigital.io?
That's it. If they want to drop me a line there and get in touch with me and my team, one of us will try and help you out. And we do a number of things. So we can actually take your images and process them for you, or we can give you some training so you can do it yourself. We have a platform that you can show your 32-bit stuff off and show 36 or 360-degree imagery off as smart images. So that's something that's our product called Rich Picks. But if they want to get in touch and just want to, you know, pick what little brain I've got left after COVID, then yeah, I'm more than happy. I'm sort of coasting towards retirement, and my mission is to try and share what I know and pay it forward. I was helped by some fantastic people early on in my career, and so I try and pay it forward as much as I can. Certain things I can't share because they're like secret sauce type. That's what the secret sauce on my barbecue. But generally speaking, there are lots of things we can help out with. Anyone who does drone photography and wants to eliminate the shadows and the dark spots or the shiny bits on that silo or grain silo or something, who are photographing pharmaceutical plants and stainless steel, yeah, we can do that.
Okay. Well, yeah,
that sort of thing.
I think we'll definitely hit you up maybe for some training in the future or something like that, and see if you're willing to share some just get some hands-on courses going. You should really think about putting something on like that.
It's something we've been thinking about. We've now spent the last 6 months or so harnessing on processes and doing some AI tricks and wrinkles that speeds up the process. It can be very labor intensive, manually intensive, human intervention. What we're trying to do is automate that as much as possible, because the issue with photogrammetry is the upside is you don't have to take 24 images and process it in your room anymore.
Right.
Okay,
Yeah.
you can take thousands, but then if you've got to do adjustments to them, you've got to find an easy workflow to do that. So yeah, so now we're the more the merrier. Anything we can do to help colorize your point clouds or make your photogrammetry look truly real. Yeah, love to help.
Great. Well, listen, Barry, thank you so much for great information. I mean, you've got a wealth of knowledge here, and yeah, I'm definitely going to have to pick your brains here in the future to do some more here.
Yeah, do it quick, because I don't know how long I'm going to last.
No problem. We'll catch up soon. But listen, thanks again. Hang back. I'm just going to pull you out here, but just hang on until we'll chat a little bit after I come back. Okay.
Okay. No problem.
Cheers. Thank you.
Okay. Bye-bye.
Bye-bye. Well, that's it, folks. Huge information there. Some really great opportunities there. And for what people are doing up front with their imagery, I think most people are just like point and shoot, and they're not paying a lot of attention to the image quality or the way they're taking the photographs. And this is a really, really important part of photogrammetry, as Barry pointed out there. So, hey, thanks a lot for listening and watching. And we'll see you next time on Click3D. Thanks. Bye-bye.